All right, so we're going to talk about the key checkpoints that you look at. There's 5 different things that we want to pay attention to when we are wiring up a transformer, and I am going to show you in this video how you do those measurements using a voltage meter. Now, this one I kind of talk about in my course quite a bit just because I'm a big Fluke fan. It's very simple. I have a V down here for voltage, an A for amperage, and the V down here, depending on the meter you have, this one, it doesn't matter if it's AC or DC, it will detect it for you, I guess. But there are meters out there that will have the V, and then if you have the squiggly lines, that is AC, and then if there's 2 just straight lines or a straight line, then that's going to be DC. And we talk about that in the course. You guys should have already read that by now and understand that basically your direct current, your DC power runs just dead straight, where the AC is kind of bouncing up and around and zigzagging all over. So you want to set your meter. What the first thing that we talk about doing is testing the primary voltage at the transformer. So what we would do is to move our meter onto the V for the voltage. Then if our transformer is already plugged into an outlet, you could test the outlet, or you can come over to your transformer, assuming that your main pigtail is plugged in. And then you can come in here, and it doesn't matter which one you do. You could put in your probes and put them into here. And then if this were actually on, then I would get my reading up here, and it should be what we call nominal voltage. So it kind of ranges. 120 is typically spot on. If you have 118, you're going to have a little less voltage coming to your transformer. If you have 122 volts, you might have a little bit more, but technically it's usually right around that 120 volt when you do your reading from right here. I think we've talked about it in this course, but if this is ever unplugged and your lights aren't working, well, that's because this isn't connected. That has to be connected, or this has to be plugged into like a timer, and then the timer does the controlling on and off. All right, so to test that, if our transformer was on and this is our primary and we had around 120 volts, we're good here. To test the secondary, and once again, primary is the high voltage, secondary is the low voltage. So to go to the secondary, we'll put one on our COM, another one on one of the voltage taps, and then we would test the reading. And since I'm testing right at the actual source, if I'm in the 13 volt tap here like this, I should be reading 13 volts. One thing that can happen is, let's say this transformer's only got 117 volts coming to the transformer. Well, I may only be 11 volts because it's only being fed 117 volts. So it's actually, you're kind of starting off negative if you want to think of it like that. You're not at that 120 benchmark number. Same thing if I were to test this and I had, let's say, 124 volts. Well, if I would have done the testing here, instead of it saying 13 volts, it might have said 14 because I've got extra voltage coming into the transformer. So kind of keep in mind that those kind of things can happen. But if you want to check the secondary side, to make sure your bus is working, you would simply just take your probe meter, put one on the common, and then one on one of the voltage taps. And a good practice would be to, when you get it hooked up or plugged in, come in and test your 12, your 13, your 14, and then your 15. Now, let's talk about amperage. So when there's a load on the transformer, and a load is, once again, we've got lights that are on, there's a load, there's something pulling from it. So if I wanted to test the primary side, which is over here, and it's hard to see, you probably can't see it, but there's a sticker here that says do not exceed 2.5 amps on the primary. Now this is a very common transformer that you'll see out there. This is a 300 watt transformer, and most of all of them are at 2.5 on the primary side. So what I would do is I would take my meter, I would move it to the amperage setting. Once again, if you have a meter that has multiple amperage settings, you want it the one with that has the squiggly lines, not the straight, because we're testing AC electric. We're testing AC electric. Then some of these meters have a clamp that literally closes. This one just has one that you can slide through like this, and all you're going to do is put this like that. And if I were to have a load, that load number would come up here on the screen. It would tell me, you know, if I were testing the primary side, somewhere between, you know, probably 0.5 to, you know, maybe 2.5 at the most. Once again, if we were to get a reading that said, let's say like 3 amps, well, then we're overloaded. We have too much of a load down here that we're going to cause problems up here because it's overloaded. And what will happen is it may work for a little bit, but eventually, maybe in 10 minutes, maybe in an hour, it's going to actually trip that secondary fuse. So this little toggle switch that you're going to see in all, sometimes they're white, sometimes they're red, sometimes they're black. That toggle switch is the secondary fuse, and it's controlling. If this is off, it controls everything. Okay, all my lights would go off. And on a 300 watt transformer and a 150 watt transformer, you're going to have one of these. Now, if you were to buy a 600 watt transformer, you're going to have 2 of them. You're going to have 2 terminal blocks, or you're going to have 2 commons that say COM 1 and then your COM 2. Each one of those COMs is basically rated, well, it's rated for 300 watts, but because we use the 80-20 rule, we only put 80% of what it's rated for. So if this is 300, we're only going to put 240. We're only going to put 240 watts on this COM because we don't want to overload it. Now, if you go a little bit over, yes, you're probably going to be fine, but I would highly recommend trying to stay around 240 watts when you're loading up a 300 watt transformer. Now, the next thing that you want to be able to measure is you want to be able to measure what the amps are, so you know if you're not exceeding or hurting yourself on the transformer on the secondary side. Now, I only have 1 wire in here. You can use multiple wires. If I needed to put 3 wires in here, I would have 2 additional ones coming right into where that is. Just because one of these spaces is taken up doesn't mean that you can't use more wire. So, you know, if I had 2 other wires and they all needed to be on the 13 volt tap, I could put 3 wires here and then 3 wires in there. That is not a problem. But when I want to know what my amperage is on any particular wire run, I'm only going to test half of the wire. So I'm going to come in here and test half the wire, not the whole wire, because that'll cancel it out. I only want to go to half of the wire, and then I'll take a look and see what my meter says when it's on half, and it'll tell me what the amperage is. On the secondary side, our amperage reading on a 12 gauge wire is around 12 amps for that particular wire, is where you kind of want to stay at. On the COM, so we're talking about all the wires that go into here, you want to stay right around 24 amps, 25 at the most, but I believe the rating is actually just 24 amps on the COM. Now, typically we're not loading them up that we're that close, but in the event you have 3, maybe even a 4th wire, or you've got a lot of lights on some long wire runs, you want to make sure all the wires that come into here, if you were to go down and do it, you can test all the wires at once. That way you don't have to add them up individually. You just put your meter once again, it goes over half of all the wires, and it will give you what that reading is. And as long as it's 24 or less, you're going to be okay. So the final thing that you're going to test for, because now we've tested our amperage on the primary side, we've tested our amperage on the low voltage side or the secondary side, we tested our voltage at the outlet here, and we tested our voltage on the secondary side. So now the fifth thing that we're going to test is we're going to test the wire that comes out of it. So if I were in the field, I would take my meter and I would come over here and I would take both of my probes and I would test this wire, and I can't do it because I'm holding my mic, but I would test this wire to see what my voltage is. Now that's what you're going to do when you're out into the field. And if you wanted to see how much voltage you have at a particular area in the system, you would want to have these exposed. Even if you've got your lights hooked up to it, that's actually better. That way you get a true reading because it's got the load on it. The system has to obviously be on, and then you can see what your voltage is. Your operating voltage for most fixtures, if you are doing a field test, is going to be between that 9 to 15 volts, depending on the manufacturers. Some of them say 10, some of them say 9, but they're typically between that 9 to 15 volts is how much power the fixture needs to operate correctly. Guys, if you have any questions on this, please ask me. It is so critical that you have a voltage meter and you know how to use it, and you do your testing when you hook up a system. Also, knowing your numbers, knowing that you can't exceed 2.5 amps here, knowing that you can't exceed 24 amps on the secondary side, knowing that you can't exceed 240 watts on this 300 watt transformer, or we have to use 80% of the capacity of the transformer, that helps you troubleshoot. So when you go out and you're having problems and you don't have lights on, or your secondary fuse won't stay on, it just shuts off, you know what to be testing for. Now that's all going to be listed in your ebook for you, so you have all that information, but it is important that you learn those numbers and you learn how to use a voltage meter.